I'm just finishing up an article in Design World where Industry 4.0 is and what the major hangups have been or slowness of its acceptance. One of the major issues has been why it hasn't caught on, of course, in the way we thought it would from 4 or 5 years ago when we collected this term 4.0 is primarily because of the return on investment. People don't want to spend the money in this they can directly tie, predictive analytics or prediction to failure, digital modeling to, what will it really save? Is it worth the manpower and investment?
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Paul Denman. Paul started his career as an engineer focused on new innovative technologies. He is passionate about technology and its integration to solve business problems and has a number of accomplishments in lab automation, AI, IoT, medical device, robotics, machine vision, and hard automation. As a member or advisor to corporate leadership, Paul is viewed as a key contributor and collaborator, credited with identifying and securing missing links that have improved corporate growth, profitability, and new product sales. Most recently, Paul has been focused on robotics, automation, and machine learning using edge analytics for Industry 4.0. Paul holds a degree in Biomedical Engineering and a Bachelor of Science in Electrical and Electronics Engineering. Thanks, Paul, for being on the program today.
Thank you.
Awesome. I gave a short background, I guess, kind of what drives you. There's a lot about innovation and sort of applying those to business problems, but maybe you can give us a little bit more detail and sort of how you got to where you are today.
I'm from Colorado, went to Colorado University. My real passion was in life science. And so I worked in cardiology research for about 5 years at CU Medical Center and got heavily steeped into microprocessor design, hardware design, that kind of thing. Later, Honeywell hired me to move to nice, warm Minnesota. So,
Sure.
And I think it's 21 below zero today. So
Exactly. It got to be a hardy Minnesotan to live here.
That's
for sure.
Right. I know. Right now, we're all looking at where could we live. I got into more commercial design, electronic software development, embedded software, and then moved into sort of a technology support area with a company called Western Digital out of Irvine. And that was a turnaround situation. I got involved with some just wonderful champions as far as business development goes. And we grew that company from about $4.5 million to $640 million in 5 years. I wish they were all that good.
Is that the same company that makes hard drives, Western Digital?
It is. We actually acquired Tandem drives when we were there, but they're the original, if you've heard of the UART or serial port on computers, they were the inventor of the first serial port chip. And good old RS-432. And then they designed and manufactured a chip in a foundry for disk drive controllers. And that soon became the industry standard, was in actually the IBM PC products and all those. So part of the whole PC wave and working at Boca Raton for IBM's first PC release and a lot of fun.
Been all over the world then, for sure.
Yeah. But more recently, in the early 2000s, I got involved with the Human Genome Project and all the automation involved with that and commercializing that technology. And that got me steeped back into life science, but less medical device and more into sequencing, cycling, genomic research, targeted vector genomics, those kind of things, and all the automation that goes with that. In the last 5 years, I've focused primarily on the space of laboratory automation and, in general, automation and everything that involves also edge analytics and industrial. And I'm assuming that's maybe where the conversation can go today.
Sure. I mean, it's all about data at the end of the day. And so how can we apply some of these new things like deep learning, machine learning AI technology is a broad term, I guess, to all this information that we're now getting from these sensors and all this crazy stuff. And it sounds like, you started at sort of the hardware level, right? You're talking about microprocessor design. Those were some of the concepts and stuff. And then Industry 4.0 feels to me like it's just a really, really broad term. It's all around, like you're talking about edge analytics, automation, improving efficiency, all those types of things, which is where you're focused on today.
I'm just finishing up an article in Design World on where Industry 4.0 is and what the major hangups have been or slowness of its acceptance. One of the major issues has been, it hasn't caught on, of course, in the way we thought it would from 4 or 5 years ago when we collected this term 4.0, is primarily because of the return on investment. People don't want to spend the money on this. They can directly tie, predictive analytics or prediction to failure, digital modeling to what will it really save? Is it worth the manpower and investment? I think the major niche that this has found recently is where does it pay to be able to predict a failure ahead of time to prevent it? Okay. It's down to like seconds. And, I talked to the VP of manufacturing for Ford last year, and he had mentioned that they have this huge conversion on assembly plants to go to electric actuators rather than pneumatic or hydraulic. And the reason for that is one actuator failing on a line for every minute. Cars are averaging somewhere around 50 to 55 seconds a new car comes off a line. What does a car cost today? 40, 50,000?
Yeah,
so
sure.
you're losing about $50,000 every minute.
Mm-hmm.
So an hour downtime is going to cost you a lot of money, right?
Yeah, for sure.
So, the payback there is obvious. So there is a big trend toward that. And in staying in that category of predictive edge kind of analytics, the other big niche right now is moved into large motor applications in the 20 to 200 horsepower size. So these would be like in the area of pumps, city waterworks, things that when it's down, it has a major impact on society or products. So it's not moved into the smaller motors and devices that, they're assembling a pacemaker or they're manufacturing a catheter or liquid dispensing in a microplate. But because the payback just isn't there, the impact isn't big enough right now. It will get there. The technology is there already, but the emphasis is on the bigger stuff right now.
Sure. No, that makes sense on sort of the bang for the buck. I mean, I've been in sort of this IoT realm for at least a decade now here. And I feel the same way with regards to it has really slowed, right? There were a lot of things I was talking about, 5, 6, 7 years ago. The whole world's going to be connected. All this data is going to come off all these things, everything, from your house to, like you said, smart city, smart factories, all that type of stuff. And it really feels like some people bit the bullet and I think did the early product development and are seeing they're reaping the rewards of it. But I saw for many, many years, a lot of companies just saying, well, we'll work on that next year. We'll work on that next year, right? What do you think has changed here? I mean, have they finally done the math to really realize what's going on? Or, in your article, I'm curious, we'll definitely post links as sort of like the liner notes of this podcast. But I'm just kind of curious to know, do you feel like we're at the turning point? Because I felt like we'd be at the turning point many, many years ago, and companies are still reluctant.
Well, everyone is talking about trillions of edge devices on the net, right? Your home thermostat, et cetera, right? And IoT is going to be massively big. I should say that, my focus has been more on the industrial, manufacturing, commercial, not home automation, which is another whole market in itself. The model's completely different there. I have a Ring doorbell that tells Amazon and tells my phone, the UPS guys at the door, right?
More of a convenience.
It is. You're right. That's a good point. It's really convenience-based. It has to be more money-based when you're talking to Ford, General Motors, Siemens, ABB, whatever, right?
Absolutely.
But just to sort of narrow the focus a little bit, there's a show in Nuremberg called SPS. It is the premier world show for motor controls and motion control. and automation, but not automation on the fact of just simple robotics. It's focused on the control of that. So the turnout typically is about 30 to 45,000 people every year. This was pre-COVID and it was canceled this year with a 1 week notice. So we had equipment on its way out there.
Oh, no. Oh, that stinks. Turn it around. Bring it
I
back.
bought tickets and everything, But that show is probably, to put a plug for that, that is the number one show to see 4.0 because there's a high focus and actually part of the convention centers are just on that subject alone. You see two major players right now and others moving into it. And I think the ones that have gotten a little ahead of the curve so far have been ABB and Siemens. And their solutions have been coming along with a cloud-based platform also. So it's a matter of collecting edge data and getting it to the cloud and then analyzing it. Siemens' product is called MindSphere and ABB is called Ability. So they have names for them. They usually run on AWS platforms. And in the case of dealing with, the China market, they run on Alibaba rather than AWS. China's insistent on that. But what they are is primarily data collectors, and then it's up to you to try to collect and analyze that data in the cloud. You can imagine that it's not real time, right? It's pretty fast. I mean, uplinks are getting with fiber pretty fast these days. But if you have something that's got very high speed cycle rates, you probably want to do more of the thinking where the motion is, not in the cloud, right? Just to make a comment about edge to cloud here is that also the game has to be completely different when you're dealing with semiconductor foundries. So, dealing with Intel, Taiwan Semiconductor, Micron, whatever, their processes are so proprietary, they quote unquote air gap the factory, right? No connection to the outside world. So what do you do with that cloud? So they're on-premise cloud systems, and that the catch term for that has been fog. It's not a cloud, it's a fog. But they have on-prem servers that are running fundamental software like Wonderware, Microsoft Azure, whatever it is, on-prem. They'll collect that data, look for anomalies, and give them real-time information.
Sure. Yeah. Basically more like a private cloud instance for them. Yeah. I mean, the other thing is even if they aren't allowed to connect to the internet, like you said, sometimes downtime happens, right? And so you need these edge devices to be able to react in a real-time fashion and not have to continually be connected to the mothership because sometimes it's just not reliable, right?
Exactly. Yep. And Microsoft, because of how far and how long they've been out there, still has a pretty good head start on what's actually down on the factory floor. So these other companies that have an edge to cloud solution are, they're offering the total package. So they're going to offer, for instance, ABB in Germany 2 years ago, pre-COVID, they introduced a little clip-on module that's Bluetooth 5.0. You clip to the motor, and usually a large one, so they're 20 horse or bigger. That Bluetooth on-prem will communicate to a hub via Bluetooth, and then that will in turn go up to whatever the servers are, wherever they are. So they're trying to provide the whole solution, right? Siemens has the same approach. They have a clip-on unit that measures the vibration, temperature, inductance variation, anomaly detection of the motor, and it's transmitting that data. I asked everyone, I was a little surprised, why Bluetooth? Do you know why?
Well, I mean, you could potentially use a phone, I guess, for it as your edge collection device.
It turns out the short range and the security of Bluetooth is harder point to point to hack than Wi-Fi. So they consider it more secure. And I think the short range, and although 5.0 is supposed to have very long range, the new standard, but theirs are very low power transmission. So then you're sort of down to, okay, I'm going to detect something. Where is it better to detect it in the cloud or on the edge? Well, the big trend or the big logical path for this is to push it to the edge, as much intelligence as you can. So now there's a trend toward what are called intelligent actuators. they're basically an integrated solution. It's a ball screw, lead screw, linear magnetic shaft motor, and it has the drive and controller and the data collection algorithm right on the actuator. The uniqueness isn't really the motor, it's the drive and controller electronics, right? There's also been a new trend toward, forget the actuator, just a motor, and on the back of the motor is a drive control electronics module, and the motor is smart. Now it's a motor you just talk to. It could be even talked to wirelessly. You can drive and run it wirelessly. So you can connect those motors to other motion devices, and there you have your fully integrated, motion control device. Now we're down to, what do you get to detect? How you get to detect it, and how fast can you detect it? And maybe fast isn't important. Maybe it is, right?
Right. Sure.
And how much data do you collect?
Yeah. What's the frequency?
There's some people right now there's a team within Amazon. The only thing they do is work with exabyte size data. You can imagine exabyte, right? That's a lot of data. Amazon's collecting a lot of data. We're not quite sure if Amazon or the government has the most right now. Amazon's rate is moving, their collection rate's moving very fast.
Like jet engines collect terabytes of information just in one flight, right?
That's right. 40 terabytes per every 2 hours. That's right.
Yeah.
And that data is collected in the black box, and that box on a Saturday or weekend is dumped to, for instance, it's GE, it's dumped to the GE data center in California. They analyze that data for outliers.
Sure. Do they still have their Predix platform at all? Is that still a thing?
They do. Predix is a package that does not really have an internal high-speed proprietary algorithm, but it's more of an approach like Siemens and ABB would have. It's data collection, simple analytics. The function of the algorithm, since we're talking about algorithms, is in most of these cases where we're at here, we're not talking about Google TensorFlow, where we're looking at, is there a cat or a dog sitting on the back of the pickup, identifying that way? That's more supervised machine learning. We're talking unsupervised and anomaly detection. So that's what the world is at for failure detection, is anomalies. The most common algorithm out there is something called K-means. You can Google it, big K with dash and then MEANS. And it's a very simple clustering algorithm that looks for basically multiple dimension data. It's been the industry standard for, 40, 50 years. It's been used. And it is still the fundamental thing that's used for clustering data and looking for patterns and looking for anomalies. There is a huge breakthrough that's been made in the area of something that could replace it at orders of magnitude faster. This Boone Logics out of Minneapolis has come up with a almost 3 orders of magnitude faster algorithm that replaces that. So that particular one that they have is a streaming algorithm. So it can learn while streaming. Everything else in the world is batch mode. You collect it, then you move it, and then you analyze it. This can do it real time. And also it can do learning and anomaly detection real time. I think has got some real traction as far as, getting out there and having a big impact. The question too is lean and low power. That's the other big advantage to this new algorithm. They call it nano appropriately because it's a very lean algorithm. They can sit on a very small processor. And in the majority of machine learning, when you're looking at, for instance, machine vision, surface flaw detection, anomaly detection, you're dealing with high volume, high velocity, all the V's, right? Lots of data moving very fast. Can you keep up? So everyone has thrown a lot of processor, high wattage power to this thing, like the NVIDIA boards that have, they're drawing watts and watts and burning lots of heat, or the TensorFlow chips at Google, you can fry an egg on them, right? So this has some really big potential in that space. I think the other trend that's having a big impact in this space is just basically the small little ARM processors that are low power, and they can be embedded onto small devices. I don't know if you're familiar with FPGAs, field programmable logic arrays. They've been the upcoming thing as far as if you really want speed. It's the fabric of, for instance, relaying out a circuit board via software. So you can embed a algorithm in a chip and design the chip in Flash that's called quote unquote fabric that would enable you to run very fast in the same way rather than using a standard CPU. But the ARM processors, ST has got, I think, version 7, they're ST7 or something. They're totally contained microprocessor, cache memory, everything, communications all on a chip. And because of the ARM architecture, they're low power and they're getting as fast or equally, possibly sometimes even faster than FPGAs at a lot less money. FPGAs are still pretty expensive. So in talking to a lot of companies that are building, Turk Banner, companies that are building sensors on factory floors, they're now embedding these. They were working on FPGAs and they've all shifted to ARM processors.
Seems like a lot of the world's moving to ARM. Apple's new laptop here is all ARM based. I've been hearing lots of great things. I still have an older Mac here, but everyone who's gotten one says it's amazing. No heat, first of all. It's like it's you don't need a fan. It's fanless, and then also just they're like, I'm getting days of battery power out of this thing. So it seems like that's where everyone's moving to these days.
Yep.
You've covered a lot here. There's just so many areas to start to dive into a little bit. I guess going back to the original thing you're talking about, somebody is manufacturing a motor that already has all of this components. It has the algorithm, it has the technology, it has the connectivity, it has all of it built into it, right? Is that kind of what you're saying? And basically manufacturers have stepped up and they've sort of built this all-in-one solution?
Smart motor has been around for the term quite a while. Because it's descriptive, it can't be copyrighted. There was an attempt to copyright that term, smart motor, but basically now it's sort of become what you might call, like you said, smart actuators. So things have become, the trend is always smaller, more compact, higher performance, right? And in a way, actually, a little bit, you're actually getting better cost savings also. Tesla will have on a line, just on the pipe for the PLC, they'll have over 50,000 sensors all running. On a controller, you've got to monitor 50,000 sensors and what's the response of that and how fast can they all communicate and detect something. It's going to be all about how do you connect all these smart edge analytics devices, which is another whole project in itself. What do you use to have them all talk? You're going to have hubs that will talk to 8 to maybe 16 edge devices that'll collect some of the data and then move it up farther to the on-prem or cloud server, right? If you got to shut a line down to replace it, then you have to plan it, ideally, right? So you want to have everybody ready there so the downtime's at a minimum. But, knowing that something could fail, Boone has been doing tests so they can predict 3 months out on their new algorithm if a motor will fail. So I think the potential for early enough warning is there now to do it.
Yeah. I mean, have you seen AI go through a couple of these, what they call AI winters, I guess, where there's lots of promises? I mean, I'm thinking about the Gartner hype cycle, and maybe where you think Industry 4.0 is in that. Are we in sort of the trough of disillusionment? Or are we getting out to the plateau of productivity? I'm sure I could the Gartner in 2022 and see where they put it. But are you feeling like we're on our way to sort of wide industry adoption with a lot of these things?
Yeah, I think people have gotten real now, right? The fact that you're collecting data doesn't necessarily mean you have the right algorithm to detect the failure. Okay, fine. I'm throwing all this up on the cloud. I'm charting an envelope of, this is the power in the motor or the current in the motor, not in a normal curve. You develop an envelope on that current curve and you're saying, okay, well, it's going outside that pattern. Now it's going more like multiple patterns. You're looking at current, position, velocity, temperature, vibration, all creating a pattern, and not very fast, obviously. And it's non-threshold based companies like Arcus Technology and people that have developed a motion controller devices that are actually pattern-based. And also Boone Logic has a pattern-based anomaly detection system for motors. So that's going to be the new trend. Pattern versus threshold. That's the big jump.
So, I mean, does a failure have to happen for then to you to say, aha, a failure happened, and now let's look back at all the data using k-means, you're saying, basically this clustering. Because when you're doing unsupervised learning, and maybe we'll step back for a second, maybe for the listeners, you could define maybe unsupervised versus supervised learning.
Unsupervised learning is where you don't know what you're collecting. You're just collecting the data, right? It could be all over the board. You don't know what it is. You're collecting this data. You're looking for patterns. Supervised is where you're supervising something, telling something. You already know what you're looking for. You're supervising an action toward a pattern that you're looking for. So facial recognition would be, supervised learning, right? Because if you're looking for a particular person, you're supervising that processor to go find that pattern.
It takes human interaction, or it takes some sort of tagging or labeling of data, right? You say, oh, this is what this cat looks like you're saying. But in these cases, I don't think you don't even know what you're looking for. You just know a failure happened, and then you kind of need to go back and let the system figure out, okay, here's a case where I led to this failure. Is that sort of
exactly what you're doing? Is you're primarily what's normal. So in a way, you supervise the learning of that process, but while it's running, it's in unsupervised mode because you're looking for an anomaly, something that's not normal. So it's sort of a pattern fit or envelope fit of, if you will, of, what's normal and not normal.
So then, is there something to be said that you have to wait for a failure to happen to then see all the things that led up to it, or not? Can you just let a motor run, even though if it doesn't fail for a year, it's still humming along? Can you still build that envelope around it and say, hey, here's normal operating conditions when it comes to vibration and voltage and temperature and all that sort of stuff? Can you still build an algorithm without actually having any failures?
That's a very good question, actually. In supervised learning, if you're looking for a failure, you need to teach it that failure. So that has to occur. You could not possibly, in a factory floor or any automation platform, conceive of all the failure modes and induce those in order to train your model. It's just virtually impossible. There can be millions of combinations. For instance, if IBM has got some platforms that they're testing fairly big ASICs on that are Lawrence Livermore Labs, and they just got, I think, the upgrade to go from 300 to 500,000 cores on their supercomputer now. And IBM's system is using that in atomic structure analysis, but they've got to teach those cores every possible combination in order to be able to do that. So that's supervised. So you're right. I mean, you can't teach it every possibility. So what you want to do is teach it long enough what's considered normal. So you can usually, if you have an actuator that, let's just say, it moves a dowel pin in a factory floor on a car in and out, it's a simple motion, right? You could cycle that 20 times and you'd have it. You don't have to run it for weeks, right? You can train the patterns fairly quickly. In some of the platforms that are out there now, you run them for 5 or 10 minutes teaching, and then you're out of the learn mode and you're back into the detection mode looking for an outlier.
Gotcha. And to bring it back to CPU cycles and stuff like that, from what I understand, it's the teaching and the building of the algorithm that actually is fairly expensive, right? Once the model's been built, you can actually run it pretty low power, right? Just to do the checking against it, the validation.
The same device this teaching is looking for an anomaly is the same processor. So it's a constant. Teaching versus running is not really usually a big power difference between the two. Yeah.
Gotcha. Okay. Yeah, I just know, like, if you go to build a neural network or something like that, in those cases, like that's where, you can actually, and you have a lot of data to run through the neural net to try and figure out how many layers, and how, what is the optimal path through it, all the math that goes on inside there, all the weights and all that sort of stuff is actually, to teach it is actually the more CPU intensive part. That's why sometimes people, as what I've heard, is they ship that data and they train the model in the cloud and then they push it back down. And in fact, there's a number of different companies that offer basically solutions like that. where you can kick it up to the cloud, and they offer a cloud-based solution, and then they can push it down to a little, just even like an Arduino. You can just have that thing sort of like running and doing a lot of the predictions with a super low power.
Now you're talking in the world of what's quote unquote deep learning, right? Not everything's deep learning. Not everything is neural nets. The world has come to accept AI as, it's a neural net. The term deep learning, the deep has to do with layers deep of the net, right? So I believe, Google's platforms, the higher performance platforms, go 50 deep on a neural net structure. So those are serious power hungry applications. You have a lot of CUDA cores, as NVIDIA would call it, running on these very big chips. And even with the smaller gate sizes, they still run really hot. Deep learning is different. If you have another way, like the Boon Logic one, or just a standard processor that's doing simple Google Analytics for anomaly detection, just standard slow sample rates on a ST3 ARM can suffice, at very low power.
No, that's great. Why bring in a huge arsenal and a lot of other complexity and power hungry?
What I've seen, even the models on, for instance, MindSphere and things, they can do it. They can spin up maybe 10,000 cores on Amazon to do a deep learning model. Google can do it on their TensorFlow platform, but it's not done that much, actually. You don't need that because, once again, you're doing your anomaly detection, right? And the model's been made simple for you. So you can do that right on the edge. You don't have to do that on the cloud.
Yeah, for sure. It feels like there are a lot of different technologies, like you said, that, somebody could just clip something onto an existing motor. Boon Logic has a unique proprietary algorithm. Siemens has a cloud. Like, it feels like, at least, for a number of years here, everyone was sort of solving a little piece of it, right? And does it feel like now that now this has become more commoditized? Like, so if I own a factory right now today, can I just, go out for low cost and kind of automate it, and just by getting standard components off the shelf?
You can. Interestingly enough, Siemens has gone open market, open architecture on their platform now. ABB has not done it, as I know. I might be incorrect on that. That news might be old, but they were talking about it. But I know Siemens is open source, so you can develop your own, pattern recognition AI platform, plug it into their MindSphere product. And I noticed they had purchased several small AI startups, one in England that was at the show several years ago. Once it gets out into the mass market, and now it's starting to come out on these low-cost motor controllers, some of the older, established, bigger motion control rack mount platforms that are out there are just now getting into it seriously and offering some version of anomaly detection.
Sure. We talked a little bit about maybe the technology, right? Whether it be k-means clustering or deep learning, there's all neural networks, there's all these sort of like different terms. But if you step it up a bit, I like to ask people, like, how do you define artificial intelligence?
I like to stay with the term machine learning.
Okay, sure.
I'm not even going there. If you ask 10 people in the room, they'd all think it was something different.
That's true. That's sort of like the thought behind the question, I guess, is what's your perspective on it?
I've got grandkids that they would all have a really interesting definition of what AI is, right? And, the term machine learning is a good term because, is it intelligent? Well, I don't know. You can give it decision-making capability, and it's making decision on data. I guess if that's AI, yes, that's AI. But I think the focus is going to be in the next couple of years here, once things cool down with the COVID issue, is getting very practical, right? Where's our return on investment? Where do they really need to detect data? And what do they need to collect? And I think in a lot of cases, we over-collect data, and we don't have to. Once you get down to the edge, you don't have to store all the data. It's more like a light switch, right? It's detecting it real time on that device. There is another big trend in motion that's coming about that's having an effect on how accurately to monitor the data. That's something in the actuator world that are called linear magnetic servo motors. And these are magnetic shafts, snip-on pulse designs and manufacture. They're the leading manufacturer of these. They have a non-cogging motor that has very high force that is a good swap out for a lot of these companies in automotive and commercial going to these because they're super compact. But as far as IoT, they're really easy to collect data. The reason is the motions can be very accurate. So you can have something pushing a 300-pound bag of grain into a baking oven, or you can have something moving a wafer. The same motor that's used for the 300-pound grain bag is used on wafer motion control at Intel that moves at 4 atoms wide. That's how accurate they are. But related to IoT, you have very tight control, closed loop control of magnetic shaft motors, better than you would have a mechanical lead screw or bearing device. And there's a lot of companies moving into that field right now. I believe Nippon Pulse has already sold over 1 million of them as of last December. So the market's growing fast. Not taught in schools. It's sort of interesting. A lot of the younger engineers aren't even familiar with them.
Yeah, it feels like in a lot of ways. I mean, my background is in software, and I hire a fair amount of engineers every year. I feel that way too, just when it comes to software development. People coming out of school, I almost called them kids, I guess, or I would date myself a little bit, but these students coming out of school, these graduates, they're learning the basics, but I feel like the first 6 to 12 months or so, I'm really making them more street smart than book smart. And I think in general, I think for the United States to compete, you need to have a lot more internships, I guess, right? So that's one of the things that we like to do at our business is have more students coming in along the way so they get a chance to sort of see what the real world is like. But then also, teach them more current things, right? It's like, yes, C++ is certainly interesting and used in some capacities, but boy, there's a lot more other Java and C# engineers, out there. And most students are going to end up using those technologies more than some of these other ones. So
definitely
getting them more involved with more modern languages, I think in some ways is a good thing.
Exactly. So you didn't mention Fortran. There's not much out there anymore.
Not that I know of. I haven't written a line ever in my career, actually. But you hear the stories.
Fortran was a big deal.
Well, you know what? I think you can still find a Fortran job, is what I've heard, and they're kind of in high demand. But I think, like everything, new technology comes along, and a lot of this old stuff sort of goes away. I mean, this kind of leads into something I do like to ask other people too. Is like, what would you advise people that are coming out of school? Like, are there classes people should be taking? You mentioned trade shows and stuff like that. That sounds awesome. If people want to get into this area, looking back at what you did, you've done over the past 5 years, what are some suggestions you'd have?
Absolutely. Number one is to get in a car or get on a plane and go to some of the major trade shows. A lot of the companies love talking to students. They love knowing about, we got to train the next generation, seeing the new stuff. And in a lot of cases, a lot of the trade shows, are showing it in action, right? So I think the big show right now coming up that's become sort of the new standard for the U.S. in automation is Automate. I believe it was in Chicago. This year it's going to be in Detroit. I think that would be a really good show for students to go and sort of see the new automation. A lot of robotics platforms, but a lot of IoT, a lot of edge analytic, machine learning things there too. So.
Yeah, awesome. I'll get some of those links here of things that you mentioned, and again, plop on the site. Obviously, just networking with people, and listening to these podcasts is really what I also like to encourage people to do. Just search around on the internet and just try and be like a sponge, absorb as much as you can.
Yeah, you can think geography. I don't know if a lot of people are aware of this, but when I work in the space of under the umbrella of life science, there are zones within the U.S. that have sort of coagulated into learning centers and a lot of students and a lot of universities focusing in that space. And it's sort of shaken out in the space of genomics right now. Boston is sort of the core, Cambridge down in Boston, that area has become the new pharma, vector genomics. Of course, I've worked with Moderna on a lot of their lab Cells, those kind of companies, Merck, AstraZeneca. That's become the pharma compound, market drug delivery, right? Northern California is now the highest focused area for IVD, in vitro diagnostics. So, anything you do with blood work, COVID testing, whatever, the majority of the companies in that space are going to be in Northern California. And now, the last remaining fellow, I don't know if you've heard of Craig Venter, who sequenced his own genome. He's left the East Coast. He was the last company to move in this space in DNA sequencing. He is now down in Southern California, along with Sequenome, Affymetrix, and Illumina, the leader in the space. So that's become the DNA sequencing area of the world. And then fourth would be actually where I am, which is quote unquote medical alley, which are primarily medical device related. So pacemakers, heart valves, catheters, a lot of the manufacturing in that space is still Minnesota.
Sure. We're huge in that space for sure. As you were talking about automation, I was looking here online because there was a group called ISA, the International Society of Automation. I'm not sure if you're familiar with them at all, but they have a Twin Cities chapter. I haven't connected with them in years, but they did have a local show I remember going to that was really around robotics, right? And training an arm to pick up a thing and keep doing it over and over again, right? A lot of this automation stuff.
There's a group called LRIG, which is Laboratory Robotics Interest Group. There's 6, I believe, or 7 different locations for that group. And there is actually, although it's a catchphrase, Medical Alley, there is a medicalalley.org organization here that usually, I believe the ex-COO of one of the big medical device companies was running that here in Minnesota. And there's Bio is another huge organization that's nationally known, and many companies are involved in that.
Sure. Well, just one last question here. I think before we kind of wind down, how do you think this is going to change the future of work, right? So as people enter the job market with all this new technology going on, and we can focus on just, I guess, industrial IoT, how do you think entering the workforce now is going to be different than it was, say, 10, 15, 20 years ago?
Well, I don't think the trend's going to change. There's going to be more emphasis on, in the software world, things are becoming more integrated, more intelligent. Surprisingly, when I'm talking to mechanical engineers, they've, in a lot of cases, are writing code, machine level even, on a motion control device. That's part of the training. It's part of the package now. So, learning, whatever field you pick, even in automation, if you're a mechanical engineering student, learning software is going to be, probably a key in some respect. So yeah, the trend I would say is going to continue toward the high ROI in machine learning, edge analytics, pushing from the cloud down to the edge, smarter devices on the edge, and some of these newer inter-factory networks.
Yeah, no, that's interesting to know. It's like no longer are mechanical engineers sitting in their silo and just kind of working in SolidWorks and drawing pictures. I, grossly simplify that, but they're working in sort of like the physical world. They're ultimately going to need to understand and cross over into this software land. Probably everybody will.
Yep.
That's a great thing to point out.
I know Nippon Pulse has come out with a new product that's called Commander, which is really an aid and assist in that space, because what you find out there is you have younger students. You can have a company like Thermo Scientific, Biorad, all these big companies, and they maybe have 10 to 15,000 employees. They might have 5 mechanical engineers in that entire base. And they usually are burdened with everything: the software, the motion, the control, the mechanical engineering of the device, loading a diagnostic tray into an analytics machine. So how do you make their life simpler, right? Do they have to reinvent the wheel? They have to learn what a closed loop servo controller is. And, they just don't want to. Why would they do that?
Right. Sure.
So there've been a lot of companies, for instance, Nippon's Commander product they have a small module, easy develop software that's almost basic, like that, a 10-year-old can set this thing up. it can coordinate the motion of four axes all automatically for you. A lot of companies are getting down to a chip level or modular level to make their life easier, right? So that's the OEM market. It's not the, factory floor car manufacturing line, but it's the OEM market where you have to build an instrument to do motion control. You got to build a circuit board. You've got to put chips on it. How complicated does that have to be, right?
Mm-hmm. Sure. Simpler is always better, for sure. Well, how can people reach out to you if they want to connect with you, Paul?
Well, you can reach out to me either on LinkedIn or direct in that way, probably.
Gotcha.
Yeah.
Okay. Well, good. Yeah, LinkedIn's just fine. I'll be sure to put a link off to your LinkedIn profile. Yeah. Is there anything else maybe you want to chat about before we wind this down, or have we covered pretty much?
Yeah, I just was wondering what your opinion of is with IoT. Where is the best, you think, source for or shows that would be based around IoT?
Yeah, I mean there are a number of ones that happen out in California. There's the like IoT World. A lot of these ones have, and of course we used to have IoT Fuse here in the Twin Cities. Who knows if that's going to be fired back up again? And of course, it's so funny because it's such a big thing. You could consider going to CES actually, right, as an IoT show because there's just a lot of automation going on. And IoT, in my opinion, really is, I guess, the sensors and the network, not so much around the machine learning and the AI piece of it, but there's just so many shows that, and when you say sensors and network, it's sort of, to me, that's like the nervous system of this entire thing that we have going on here, which is, making the world smart. And that touches everything from consumers to embedded devices. You're talking about medical devices to industrial. So yeah, I think, frankly, I always kind of thought the term IoT was just going to go away. I always sort of thought it had a shelf life of it because at the end of the day, in the next couple of years or next, 5 to 10 years, everything is going to be smart. And the term IoT is going to kind of feel dated. It's going to feel like machine to machine, what people used to say.
I agree with you. And, I think the hype with IoT, AI, whatever, like you said, on the productivity section of this right now, it's trying to, I think it's settled down and a lot of money has been lost with all these startups, claiming AI capability or applications with AI. But, an interesting fact, just maybe related to this as far as machine learning, I have a couple of friends that just graduated a couple of years ago, PhDs, University of Minnesota. I went to a doctorate defense with them. There were 8 PhDs graduating. And I asked, where are the other 6 going? I'm just curious. They said they're going dark. And I said, well, what do you mean by that? He said, they're all going to Wall Street. Yep. Wall Street gobbles up the majority of the high grade, high performance students with, postdoc that are in machine learning right now.
Interesting. So it's a lot of micro trades, I guess, right? Is that pretty much what you're saying? It's just a lot of people doing these tradings?
Yeah, it's all about machine learning and trying to get down to high frequency training. It's not there yet, but it's getting close.
I wouldn't doubt it at all. I mean, you talk about wanting to make money, I guess. You can stop a company from shutting down their car production here and save them, like you said, $50,000. But on Wall Street, you could probably make even more.
Yeah, exactly.
if you do the right trade at the right time, for sure. Oh, awesome, Paul. Well, I appreciate the time today. I thought we've had an awesome conversation. And yeah, we haven't really delved into Industry 4.0 in any of the previous podcasts that we did. So I appreciate you coming on the program here and, giving just a really good, not only a high level overview in terms of like what it is, but also, getting down into the details of really the true impact that businesses can see, in using it. So I think this is going to be a great program.
I think it's going to be exciting to see what happens this next year once we get back to normal life. It's given a lot of people a lot of time to think and figure out where do they really want to efficiently spend their time on product development also. And in a way, it's been good in that respect. People are trying to get more, better focus, if you will.
I feel like it's, at least in the like computer vision area, it feels like it's matured a little bit more. It feels like, you don't need to train a lot of these things, or like you said, it's very easy to train them where, years ago there was a huge technology curve you needed to learn to do this. And now it feels like a lot of these things are sort of coming either pre-trained or very easy to train.
Exactly.
So that's good for all of us that don't have a PhD in neural networks
Exactly.
or data science.
Exactly.
Well, good. All right, Paul, will you take care? Thanks again for the time today, and I know we'll be in touch in the future.
Thank you.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.